This is a question from network security. Using RSA algorithm, if P equal to 13, Q equal to 5, E equal to 7, then the value of D and the cipher value of 6 with E comma N as keys are what? So first of all, let's understand the RSA algorithm, which is a 6-step algorithm. We calculate the value of N using product of P and Q, where P and Q are prime numbers. Now we calculate phi of N, which is equal to P minus 1 into Q minus 1. Then we create a private key D such that GCD of phi of n comma D equal to 1. Then we consider E as a public key such that E into D mod phi of n is equal to 1. Now the cipher text will be calculated as message raised to E mod phi of mod n, and cipher and the deciphered text based on cipher text is C raised to D mod n. So based on the algorithm and the values given, let's calculate the value of D and the cipher value of 6. So initially let's calculate n. N is equal to P into Q, that is 13 into 5, which is equal to 65. Now let's calculate the value of phi of n, that is equal to P minus 1 into Q minus 1, that is 12 into 4, which is equal to 48. Now we have to find the value of D, but the value of E is already given. So using that we can calculate the value of D, that is E into D mod phi of n equal to 1. Given that E equal to 7, so we are calculating 7 into D mod phi of n, that is 48, is equal to 1. So here if D is equal to 7, then we'll get 49 mod 48 is equal to 1. This statement is true. So the value of D is fixed as 7. That is one part is complete. D is equal to 7. Next, the value of cipher text of 6 with keys E comma N is calculated as what? So the cipher text is M raised to E mod N. So message is 6. E is given as 7 mod N is equal to 65. This will result in value of 46. So the value of cipher text is 46 and the value of D is equal to 7. So 7 comma 46 will be the correct answer. So option C is the right choice. This is a question from network security. Using RSA algorithm, if P equal to 13, Q equal to 5, E equal to 7, the value of D and cipher value of 6 with E comma N as key is what? So what is the basic concept of RSA algorithm? The basic steps are, in step 1, we calculate the value of N using P into Q, where P and Q are sufficiently large prime numbers. Then we calculate phi of N, that is equal to P minus 1 into Q minus 1. Now we consider the private key, that is D, such that phi GCD of phi of n comma D, GCD of phi of n comma D is equal to 1. Now we consider the public key E such that E into D mod phi of n is equal to 1. Now we create the cipher text based on cipher text is equal to, let M be the message, M raised to E mod n, and the deciphered text or the original message is calculated as cipher text. Let's denote it as C raised to D mod n. This is the basic RSA algorithm. So here we are given P equal to 13 and Q equal to 5. So let's calculate n, that is 13 into 5. So 13 into 5 is equal to 65. So we are having the value of n. Next step is to calculate phi of n. Phi of n is equal to p minus 1 into q minus 1. So 12 into 4, that is 48. So 48. Next we have to calculate actually private key D. But since D is what we have to calculate, we are having the value of E also. So we are skipping the third step and going directly to fourth step, because E is calculated based on the formula E into D mod phi of n equal to 1. We are having the value of E and phi of n. So based on that, we will calculate the value of D. So here E is equal to 7 into some value D modulus phi of n should be equal to 1. So phi of n is 48. So using D as 7, if D equal to 7, then we'll have 7 into 7 49 mod 48 equal to 1. This will be true. So we can say that D is equal to 7. This is the first value of D and the solution to D. D is equal to 7. Now the cipher value of E comma n. It is given that cipher value of 6 with E comma n as the key. So we are asked to create a cipher value. So the cipher value can be calculated as follows.